It is
motor, sir.
induction motor drives, right?
Yes, sir.
Induction motor drives we are talking about. Now hopefully everybody in this class knows that what this induction motor drive means. So an electrical drive in which we are using induction motor as a prime mover, that will be called as induction motor drive, right? Is this clear? I think very much clear to the class. Okay. Now because your induction motor
हेलो
in
सर.
an induction motor drive, hello,
सर वो थोड़ा
बोल,
बीच में डिस्कनेक्ट हो गया था सर, वो अटेंडेंस के लिए वो.
क्या नाम है भाई?
रक्षित 5121.
5121. ठीक है.
थैंक यू
Now,
सर.
so we are discussing about the induction motor drive, right? And we know that induction motor is a key component of any, well, means electric drive is a key component of any electric drive, and obviously in this case then induction motor will be a key component, right? We have discussed about the behavior of the induction motor drive, and we have tried to get the answers to the certain questions, just like why do we call it as induction motor drive? Why do we call it as induction motor drive? Who will answer to me? Why we call it as induction motor? Anyone from the class? Why this name is given induction motor? Answer is, what is the answer?
सर म्यूचुअल इंडक्शन से एनर्जी ए में जनरेट होती है.
कहां पर?
सर रोटर में.
एनीवन एल्स? ठीक है सौरभ, कुछ हद तक. और कोई? रक्षित आप बताएंगे?
सर बिकॉज सर बिकॉज द करंट इंड्यूस्ड इन द रोटर वो फ्रॉम द रोटेटिंग मैग्नेटिक फील्ड की वजह से होता है सर.
तो रोटेटिंग मोटर कहते थे, इंडक्शन मोटर नाम क्यों दिया गया?
Because the current is induced in the rotor.
EMF induced हो जाता है सर रोटर में.
हाँ हाँ बोलिए बोलिए, और कोई बोलो इसके अलावा. बोलो बच्चों, और कौन जवाब देगा? और कोई जवाब देगा क्या? Why do we call this motor as induction motor? Because as been told by the students that we supply the energy from the supply to the stator windings, right? To the stator windings via conduction. Whereas the rotor conductors which are placed on the rotor outer surface, they receives the energy from the stator winding by the means of
Mutual
induction, right? By the means of induction. That's why we call this motor as induction motor. Is this clear?
Yes,
Answer
sir.
is because the energy received by the rotor is through the induction. That's why we call it as induction motor. Okay. Now the question is, suppose ki why this motor is called as, why do we call this motor as singly excited motor? Why do we call it as singly excited?
क्योंकि सर स्टेटर ही एनर्जाइज्ड होता है.
Very good. Very good. Anyone else? Akash Midha? Akash? क्यों कह रहे हैं सिंगली एक्साइटेड? अरे एम आई ऑडिबल आकाश?
यस सर, यस सर.
बता सकते क्यों सिंगली एक्साइटेड कह रहे हैं?
नो सर.
क्यों? दिक्कत क्या है बताने में? आकाश?
तो नहीं है सर, बस
है?
अभी थोड़ा थोड़ा अभी पढ़ना शुरू करा है सर.
मैंने पढ़ना तो अभी शुरू किया, लेकिन बता दो, तुम बताना नहीं चाह रहे. देखो ठीक है, नहीं बताना चाहते तो कोई बात नहीं है ना. बात यह है कि ये बात जो लोग पढ़ रहे हैं, क्योंकि किसी ने अभी पढ़ना शुरू नहीं किया है, तो जब वो पढ़ेगा तब उसे पता चलेगा. लेकिन जो पढ़ रहे हैं उन्हें ये बात तो पता होगी कि जितने भी ये इलेक्ट्रोमैकेनिकल एनर्जी कन्वर्जन डिवाइसेस हैं, कौन से? इलेक्ट्रोमैकेनिकल एनर्जी कन्वर्जन डिवाइसेस, इलेक्ट्रोमैकेनिकल energy conversion devices. Electromechanical means those which convert electrical energy into the mechanical energy, or which converts mechanical energy into the electrical energy. Obviously motor are those electromechanical energy conversion device which converts electrical energy into the mechanical energy, right? So any of the electromechanical energy device, they have windings on the stator and the rotor. So they have the two circuits, right? They have two electrical circuits. You can see it like this, right? They have two electrical circuits, one placed on the stator, other placed on the rotor, right? If you consider an example of a DC motor, you will remember that what we were doing was we were exciting the stator winding as well as the rotor winding by the EMF sources, by the voltage sources. Do you remember that? Do you remember that? How many of students remember that? Yes, in case of DC motors, we were giving energy to the field winding as well as the armature winding. How many of you remember? Raise your hands. Only one? Harsh was only present? Oh, I think many of you are not listening to me. Eh? Okay, fine. But yes, I guess you remember that we were energizing both the circuits, one which is being placed on the field and other which is being placed on the rotor, that we were calling it as armature, right? So we were exciting the both. Now see the case of this induction motor. In this motor, what we are doing, we are only energizing the stator winding through the supply, whereas rotor is not being directly connected to any supply. We are not supplying electricity or electrical energy to this rotor winding, but this rotor winding receives the energy from the stator winding itself by the means of induction. So that's why this motor is called as singly excited, because we only excite the stator winding. We are only giving, or we are only connecting the stator winding to the supply. Is this clear, bachcho? Is this clear? अरे हाँ ना, कुछ बोलिए.
Yes, sir. Clear.
Now next question is, let me see who will answer to this. Just raise your hand who knows the answer. Why do we call it means the induction motor as asynchronous motor? Why do we call it as asynchronous motor? Let me see who knows the answer. Akshay knows, Astu knows, Vihan also wants to say something. Let us give this opportunity to the one who has raised the hand on the miss, who has first raised the hand, and that is Akshay. Akshay?
यस सर. सर वो रिलेटिव स्पीड अगर मतलब स्लिप जो होता है वो अगर मान लो जो सिंक्रोनस स्पीड की इक्वल हो जाए मोटर की जो स्पीड होती है, तो फिर वो क्या कहते हैं टॉर्क एक्ट करना बंद हो जाता है और फिर सिर्फ मोटर की स्पीड स्लो,
आकाश मीदा आप बता सकते हैं?
स्लो हो जाती है.
आकाश?
यस सर.
हाँ, आपको
सर
याद आ गया होगा?
क्योंकि इंडक्शन मोटर की जो स्पीड होती है वो सिंक्रोनस से कम होती है.
अच्छा, और कोई? ठीक है.
यस सर.
और कोई बोलना चाहे? अभिजीत बताएंगे? Right. Basically, because your induction motor cannot operate at a synchronous speed, that's why we call it as asynchronous motor. It can operate at any of the speed except this synchronous speed. Now, why does it cannot operate at a synchronous speed? Why it cannot operate at a synchronous speed? Next question is, why induction motor cannot operate at synchronous speed? Raise your hands who wants to answer this. Ayush Agrawal only wants to say. Okay, Ayush, can you choose someone from the class from which we should get the answer? जिसने अभी तक कुछ बोला नहीं है. Again, and the strength of the class is too low. I don't know why, but there are many people who have marked their attendance. So I think they have left this meeting. हाँ आयुष बताओ. बताओ कौन बताना चाहता है? Why induction motor cannot operate at a synchronous speed? Why it cannot operate? अभी तो आंसर किया था सर. हाँ कुमार आदित्य बताओ.
सर क्योंकि सर वो डिफरेंस होता है फ्लक्स में, और रोटर पे टॉर्क लगेगा तो उसकी स्पीड फिर कम हो जाती है. और स्पीड उसकी सिंक्रोनस स्पीड से कम होती जाती है, तो फिर सर इसीलिए वो उससे ऊपर कभी नहीं जा सकता है सिंक्रोनस स्पीड से.
बेसिकली जो रोटेटिंग मैग्नेटिक फील्ड है वो एयर गैप में रोटेट कर रहा है, यही कहना चाह रहे हो?
यस सर.
It rotates in the air gap with the speed of synchronous, but the conductor which is being placed over the rotor, if they also starts rotating at a synchronous speed, then what will happen? They both will appear stationary to each other, and your flux cutting action that will not be going to happen with these conductors, right? And once EMF means once flux cutting action will not be there will not be any EMF induced in these conductors. That we call it as E2, right? Once EMF will not be there, obviously there will not be any current flow. There will not be any current flow क्योंकि EMF ही नहीं है तो current कहाँ से होगा? And if there will not be any EMF, there will not be any current, and if there will not be any current, there will not be any force that will be applied or that will be exerted or that will be experienced by this conductor, because we know that only the current carrying conductors when placed in a magnetic field, they experiences a force, right? So this is the reason that's why this motor cannot operate at a synchronous speed, because at your flux, rotating magnetic flux, it also rotates with the synchronous speed, and if your conductors somehow achieves that speed, that means there will not be any relative difference in the speed of the conductor, rotor conductor, and the rotating magnetic field, and because of this there will not be any flux cutting action happening, and because of that there will not be any EMF induced on the rotor conductors, right? I think it's clear to the class. Yes or no?
Yes sir.
Yes sir.
Okay, so it's very I think clear. Now what is the expression of this synchronous speed? Raise your hands. What is the mathematical expression of the synchronous speed? Synchronous speed is given by a relation. Who will tell to me? Daksh, बता सकते हैं कि बेटा? दक्ष,
Yes sir.
बताओ जरा सिंक्रोनस स्पीड का क्या रिलेशनशिप है, क्या एक्सप्रेशन है इसका, बोलो.
Sir, F into 60 by N.
हाँ,
By N.
ये कहाँ सीखा तुमने?
Number of poles.
इट इज 120 F by P. दक्ष याद करो भाई, तुम तो गड़बड़ा जा रहे हो. अभी तो मशीन्स की कहानी चल रही है, इसमें कंट्रोल सिस्टम भी लगाना है, पावर इलेक्ट्रॉनिक्स भी लगानी है, ठीक है? तो सिंक्रोनस स्पीड इज बीइंग गिवन बाय 120 F by P. दिस इज द रिलेशनशिप. देख एक बार बोलोगे क्या है सिंक्रोनस स्पीड का फॉर्मूला? हाँ
Sir, 120 F by P.
वेयर F इज व्हाट? F is the frequency of what?
Sir,
फ्रीक्वेंसी ऑफ द सप्लाई. सप्लाई मींस जो इलेक्ट्रिकल सप्लाई आप फीड कर रहे हो उसकी फ्रीक्वेंसी क्या है. अगर ये 50 हर्ट्ज की है तो दिस F will be 50 हर्ट्ज, राइट? एंड P is what? P is the number of poles of what? Of the motor.
Stator.
Right? Stator means poles of the stator of the motor, right? That is motor. I think it's clear. Is it clear, bachcho?
Yes, sir.
Let us take
Yes,
one
sir.
example. If this is clear, then suppose we have a three-phase motor. Everybody take out your pen and paper. A three-phase, if we are having a three-phase 50 hertz motor, right? And that motor is an induction motor. And if it has a full load speed, it has a full load speed of 1440 RPM, right? What we had to do for this motor, we had to calculate the following things, right? We have to calculate the following. First, suppose we want to calculate the number of poles. So give me the answer. How many will be the number of poles for this machine?
4 sir.
4?
सर 4.166 आ रहा है वैसे तो, बट अप्रोक्सीमेटली 4 ले लेंगे.
Right. क्योंकि your poles will be always in pairs, so that means they will be in always will be in even number or odd number. They will be in even number, right? Your poles must be in even number. So कितना आया आंसर सब बताओ. Everybody write the number of poles for this machine.
4 आया.
4 आया. How you have calculated? Obviously you have tried
Sir,
to have
120 F by P.
Yes, you know that your synchronous speed is 120 F by P, right? Obviously this is the rated speed. That means it is the speed, it is the full load speed, right? That means it is the full load speed of that motor. That means your motor runs at that speed with the full load. Okay. So what this information gives you is that what is the value. This is giving you that your motor will be running near to the synchronous speed at 1440 RPM. So you can consider it will be an approximate value of the synchronous speed, right? Exactly this will not be the synchronous speed. How much will be the synchronous speed? With this we can calculate if we know the number of poles, right? In this we will consider this to be NS, 1440 to be the NS. Obviously frequency they have given is 50 hertz. So we can be able to calculate the P. How much is the P? P is coming to be 1 by 6, right?
4.
Yes sir.
But we know that your number of poles, because the number of poles must be even, right? Must be even. That's why even and a whole number. That's why we'll select this P to be equals to 4. Right? We'll select this P to be equals to 4. Now, if we have answered this question, can you tell me what will be the value of slip at this speed? What will be the full load slip? What will be the value of full load slip? Everybody write your answer in the chat box. Value of full load slip. I will be again taking the attendance at 3:35. And I will mark absent to those students who are not being there. Give me the values of the full load slip. सौरभ बता सकते हो बेटा सिंक्रोनस स्पीड का स्लिप का एक्सप्रेशन क्या है हमने पढ़ा था?
सर ns माइनस nr बाय ns।
राइट, इट इज ns माइनस nr ओवर ns, है ना? ns की वैल्यू हमारे पास कितनी है? इफ p
1440
नहीं, ns इज 120 f by p, तो ns कितनी होगी? ns विल बी 120 इंटू 50। पोल हमें पता है इस मोटर के कितने हैं? 4। अगर ये 4 पोल मोटर है तो इसकी ns जो होगी इट विल बी 1500 आरपीएम। nr इज 1440, रोटर स्पीड उसकी 1440 है, लेकिन सिंक्रोनस स्पीड कितनी है? 1500 है। यही तो हमने पढ़ा था कि जो तुम्हारी मोटर है वो सिंक्रोनस स्पीड पे नहीं घूम सकती, उससे कुछ कम पे चलेगी फुल लोड पे, है ना? तो यहां से दिख रहा है कि इसकी सिंक्रोनस स्पीड 1500 आरपीएम है, लेकिन ये चल कितने पे रही है? 1440 आरपीएम पे। इसलिए स्लिप की वैल्यू कैसे निकलेगी? इट विल बी 1500 माइनस 1440 डिवाइडेड बाय 1500। तो हाउ मच इज द वैल्यू यू आर गेटिंग?
0.04.
0.04 sir।
Right, 0.04. And if we want, someone wants it to be in percentage, how much percent it will be? 4%. So your slip will be 4% in this case. Slip at full load will be 4%. Slip at full load, right? जब मोटर के अंदर, मोटर के ऊपर पूरा लोड लगा हुआ है तो वो 1440 आरपीएम पे घूमती है, जबकि वो 4 पोल मोटर है, इसका मतलब उसकी 1500 आरपीएम जो है सिंक्रोनस स्पीड है। ठीक है, तो अगर वहां से हम स्लिप की वैल्यू कैलकुलेट करना चाहें तो वो मिलेगी 4%। इज दिस क्लियर? One more question, that in this only, will you be able to calculate the rotor frequency? Rotor frequency means the frequency on the rotor side, right? Frequency on the rotor side. How much will be the rotor frequency? We know that if F2 is the rotor frequency, then it will be equals to S times of F1, where F1 is the stator side frequency and F2 is the rotor side frequency. Is this clear?
Yes, sir.
Anna? And it is because of the relative motion also. And if your means at the time of starting, obviously your F2 will be equals to F1, क्योंकि स्टार्टिंग में स्लिप की वैल्यू कितनी होगी? स्लिप की वैल्यू कितनी होगी स्टार्टिंग में? बताओ, रोटर फ्रीक्वेंसी कितनी होगी इस केस में? हाउ मच इट विल बी?
So 2.
Right, it will be 2 hertz. It will be 2 hertz because stator side frequency is 50 hertz. Slip at full load will be this much. So at full load, the frequency of the rotor will be, frequency on the rotor side will be 2 hertz. Is this clear, बच्चों? बताइए.
Yes, sir.
Did you get the concept?
Yes sir।
Okay, fine. So let us move ahead. Let us move ahead. Let us see the equivalent circuit analysis on the basis of equivalent circuit. This is a very important topic and you must understand this. I'm not going in a much detail, but making directly the equivalent circuit which you could have learned for an induction motor. If you remember that your equivalent circuit of an induction motor is somewhat similar to the equivalent circuit of a transformer, right? As your induction motor is similar to transformer in many ways. Right? So if we see the equivalent circuit, there we will have the impedances of the stator side and the rotor side. Obviously, one circuit is being there. These will be representing the stator side impedances, whereas these will be representing the rotor side impedances, right? we have considered that we have referred the rotor side impedance to the stator side, right? That's why we'll be denoting this reactance of the rotor side by XR dash and this resistor of the rotor side by RR dash by S. Okay, the stator side resistance is being denoted by RS, the reactance by XS. This is basically, this branch is not being present physically because we only have the windings on the stator and the rotor, right? We don't have any mutual winding, but this winding is being used to basically show the mutual reactance between the, or mutual induction between the two, right? Is this fine? Why we are calling it as XR dash and RR dash as the stator side referred values? Because we know there is no electrical connection between the stator and the rotor windings, although we have considered this for the simplification of the process, right? And these are the, because of that only, they are the rotor side values referred to the stator side, right? Do you know the meaning of referencing or referring? Hopefully you could have read those in case of transformers, है ना? पढ़ा होगा रेफरेंस, रेफर करने का मतलब पढ़ा है? बताओ
सर एक बार फिर से बता दीजिए.
Referring means only कि once we are referring a quantity from one side to another, that means we had to only count the number of turns of that side, right? अगर हम स्टेटर से रोटर साइड ले जा रहे हैं या रोटर से स्टेटर साइड ले जा रहे हैं, तो आपने देखा होगा what we do in case of transformers कि if there are N1 turns on this side and N2 turns on this side, and we had to refer this resistance R2 towards this R1, right? Suppose we want to now make this equivalent circuit, that this is R1 and this is R2 dash. Then what will be the new value of this R2 dash in terms of R2? It will be that your R2 dash will be equals to N1 by N2 square into R2. This will be the new value. We are counting the effect which will be happening because of these number of turns, right? So similar case is being there. Similar case is being here, that we will be counting the effect of the number of turns that will be associated with the stator winding as well as with the rotor winding, right? And because these two quantities are associated with the rotor winding, but what we are considering is connected with the stator winding. So that means they are being referred from the rotor to the stator side, right? Actually it is on the rotor, but what we are doing, we are considering it to be on stator side. So for considering that to be on stator side, we had to include the effect of turns which could have been there, right? So this XR dash and RR dash are basically values referred, rotor side values referred to the stator side, right? That's why this equivalent circuit they are writing as per phase equivalent circuit. Per phase equivalent circuit referred to stator side. Or stator referred per phase equivalent circuit. Okay, is this clear, बच्चों?
Yes sir.
One more thing which I want to clarify over here is, you see, we all know that your resistance, if we see the rotor circuit, right? Your rotor circuit means the rotor side winding. If we want to make an equivalent circuit of the rotor circuit, how will we make? We'll make this in a simplified way. Thus there will be a reactance X2 and there will be a resistance R2, right? Obviously, the EMF that will be induced on the rotor side will be S time of E2. If E2 is the EMF that get induced on the rotor conductors when your rotor is stand still, right? भाई ये बात तो सही है ना कि जैसे जैसे स्पीड बढ़ेगी जो EMF है वो कम होने लगेगा, यस और नो? और अगर सिंक्रोनस स्पीड पे घूमने लगी तो EMF 0 हो जाएगा. दैट मीन्स योर EMF इज related to that relative speed. So EMF that is being induced on the rotor side is basically S time of E2. If E2 is the EMF induced in the rotor circuit at standstill, right? Is this clear, बच्चों? Is this clear?
Yes sir.
है ना? अब सुनो, अगर मैं स्लिप किसी एट एनी स्लिप की बात कर रहा हूं कि एट एनी स्लिप S, the EMF will be SE2. By E2 was the EMF when it was at standstill, right? Now at any slip S, your EMF will be SE2. Then obviously your reactance X2 will also be S time of X2. Will it be? Will it be? By reactance X2 is defined as what? 2 pi F2 L2, है ना? Where L2 and F2 is the frequency, F2 is the rotor side frequency at standstill. Obviously this F2 will be equals to F1 if it is at standstill. बोलो भाई, अगर रोटर रुका हुआ है तो F2 और F1 इक्वल होंगे ना? रोटर साइड फ्रीक्वेंसी और स्टेटर साइड फ्रीक्वेंसी दोनों इक्वल होंगी. तो जो X2 है it will be 2 pi F2 L2. So we can write it as 2 pi F1 L2 if X2 is the reactance of stator of the rotor winding at standstill, right? Now at any slip S, what will be the reactance? At any slip S, the reactance will be 2 pi, this frequency will become as SF2. Yes or no? अरे बात समझ में आ रही है कि नहीं? बताओ जल्दी बताओ, बात कुछ समझ में आई? मैं बोल रहा हूं कि if X2 is the reactance of the rotor circuit at standstill, means NR equals to 0, right? So obviously this will be equals to 2 pi F2 L2, where L2 is the inductive or inductance of the rotor winding. F2 is the frequency of the rotor at standstill. So obviously this F2 will be equals to F1. So we can write it as F1 also. Hardly there will be a significance, or hardly there will be a difference between the F2 and F1 at standstill. So your X2 is the reactance, rotor side reactance at standstill. Now if we talk about at any slip S, suppose your motor is rotating at some speed, now NR is not 0, and at that time let the slip is S. So what will be the value of reactance? Obviously the reactance value will be equals to 2 pi S time of F2 into L2. This will be the new value of reactance. Yes or no?
Yes sir.
If we see this, it is what? It is, we can write it as S time of 2 pi F2 L2, right? And 2 pi F2 L2 is X2 again. So new value will be S time of X2. So at any slip S, if the EMF will be SE2, your reactance will be S of X2. Is this clear?
Yes sir.
At that time, if EMF will be there, the path is closed, there will be a current flow, and we'll call it as rotor current I2. What we'll call it as? We'll call it as rotor current I2. Now what will be the value of I2? I2 will be equals to EMF at any slip S. So at any slip S, rotor current I2 will be equal to S time of E2, that is the voltage divided by the Z, by I is equal to V by Z. V is SE2. How much is the Z on this side? कितना निकलेगा इसका Z? बताओ. It will be R2 plus J times of SX2. If we talk about the magnitude, then it will be under root R2 square plus कितना होगा? S square X2 square. Yes or no? This will be the value of rotor current for this circuit. इस सर्किट में करंट की बात करें तो यही होगा ना कि S टाइम ऑफ E2 डिवाइडेड बाय द इंपीडेंस ऑफ दिस सर्किट. बोलो.
Yes, sir.
So it will be equals to this one. Just to simplify the things, because at any slip S, your two variables are being affected. Your two variables are being affected. One is the EMF and other is the reactance. So to basically minimize this, what simplification has been made, that they have taken this S to be common. They have taken out this S to be common, right? And what they have written is, we can write this I2 as E2 divided by R2 by S plus J times of X2. Can we write this like this way? I2. Batao. Can we write it like this way? If it's this one.
Yes, sir.
Right? So, because of this, what they have done, they have now excluded the on E2 and X2, but imaginarily they have, or basically this is the equivalent effect which they have considered over a single variable, that is R2. Although we know that resistance is not affected by the frequency. Resistance in an actual machine will remain as it is, whether it is being operated at 0 speed or at synchronous speed. But to make the equivalent circuit, to make the simplified equivalent circuit, we have considered that this effect over this R2, right? That's why if you see this equivalent circuit, you will find that there is an effect of this slip which is being shown on this R, not on XR. Is this clear now? Is this clear now, बच्चों?
Yes,
अरे बोलो, कुछ तो बोलो.
Yes, sir. Yes, sir.
हाँ? तो this will be the equivalent circuit. Refer to the stator side. I think now this picture is clear why this S is being associated with the resistance, not with the reactance of the rotor circuit, right? See, to make it more simplified, what the researchers have suggested is that there will be a effect, right, if we shift this shunt branch to this side, right? And this will simplify the analysis further. So that will be an approximate equivalent circuit where we will have RS, XS, and XR or RR, let it be XR dash and RR dash by S. Okay? Your shunt branch XM is being shifted to the leftmost side. V is the applied voltage across here, right? Now the current that flows to the rotor circuit is termed as the IR. Let it be rotor current IR. This is XR dash and this is RR dash by S. Now for this circuit, can we calculate the value of IR? How much will be the value of IR? Who will tell to me the value of IR? IR will be equal to magnitude of IR. How much will it be? Let it be IR dash because it is being on the stator side. quantity. So how much it will be? It will be the voltage, but this is the voltage which we are applying, V, and if we divide it by the impedance of this circuit, we will get the value of IR. Yes or no?
Yes,
अरे
sir.
सो गए क्या? बताओ भाई.
Yes, sir.
हाँ, सौरभ
यस सर.
क्या चल रहा है? नहीं आ रही बात समझ में? अरे करंट कैसे
सर, नहीं.
निकलेगा?
सर
करंट,
ये वाला एक बार फिर से समझा दो.
मैं कह रहा हूं करंट कैसे निकलेगा किसी भी सर्किट के अंदर? I will be equals to V by Z ना?
यस सर.
Where Z will be the impedance. भाई अगर सर्किट के अंदर R, L और C मौजूद हैं तो हम उसमें केवल R नहीं निकालते, उसका टोटल इंपीडेंस निकालते हैं, राइट?
यस सर.
तो अगर यहां भी बात करें सर्किट में, इस सर्किट के करंट की बात करें कि जो इसमें फ्लो करेगा, तो कितना होगा? जितना इसके अक्रॉस वोल्टेज है और जितना इसका इंपीडेंस है, क्योंकि IR इज द करंट दैट इज फ्लोइंग इन दिस ब्रांच. तो IR will be equals to V, that voltage that is being applied, because they both are in parallel, these two branches. तो जो वोल्टेज यहाँ अप्लाई कर रहे हैं वो इसके अक्रॉस भी कर रहे हैं. तो योर IR will be equals to V, this V divided by the impedance of the circuit. Yes or no?
यस सर.
So IR will be equals to V divided by the impedance. How much is the impedance? Impedance is these two resistance are in series and these two are in series. So can we write the total impedance as RS plus RR dash by S plus J times XS plus XR dash? Can we denote it by like this way?
यस सर.
The total impedance. So obviously this will be the value. This will be the value of the current that will be flowing in the rotor circuit, right? चलो आज इतना ही कर लेते हैं.